Hi everyone, this is Andrew Delernia and I will be your instructor again for Math 273 Statistical Modeling this semester. In case you haven't seen it, there's a welcome video for the course posted on the Moodle page, as well as a short video going through the syllabus in the Moodle page posted to Moodle as well. So if you haven't watched those, please do real quick before you view this. They're only 10 and 5 minutes respectively, so it shouldn't be too bad. Otherwise, welcome back. And this will be the first sort of asynchronous lecture, me going through slides essentially. So welcome again, and we'll go ahead and get started. So in this course, we're going to talk about statistical models and predictive modeling in general. So predictive modeling is sort of referring to the process of just using data to predict outcomes or variables, often that have yet to occur. So in practice, we're typically trying to forecast or estimate something that's unknown, be it unknown now or unknown because it's in the future. And so we can use data collected on past events to do this effectively. So some examples of this would be predicting the selling value of a home, given that you know certain variables about this home, such as its size and square footage, the number of bedrooms, and how old it is in years. You can think, for example, some website such as Zillow or some other website that prices out what your home should cost, takes into account factors such as these when giving a price estimates for what you should sell your house for example. Another example would be predicting the national unemployment rate, and to do that we could use historical data, so previous unemployment rates. There's certain seasonal effects given the month, the time of the year that need to be accounted for when estimating these things, and clearly, for example, the unemployment rate the previous month will be very informative of the unemployment rate the next month as well. So this is another thing that is very important to estimate or predict. And a third example, Google does this. So you probably notice with your Gmail, sometimes some emails come in and Google will flag them as spam, which is really helpful. They didn't always do that. That's a very cool new innovation that they do. So Google parses the text, looks at the text in the email, and can estimate the probability, essentially, of it being spam. And so if it thinks that's high enough, based on certain characteristics of the email, such as the number of consecutive capital letters, then it might flag it as spam if it thinks that threshold is high enough. So you can imagine a spam email might have a ton of caps. Sometimes they're very strange like that, but normal emails typically don't. So they can use a predictive model in this way. So some key terms regarding statistical models to start. We'll define what an observational unit is. So we define this as being people, objects, or cases on which data are recorded. So in the previous example, talking about emails, the email was the observational unit because we were measuring characteristics about it to estimate if it was spam or not. Another key concept is the concept of what a variable is. So variables we define as characteristics that are measured or recorded about each observational unit. So again, going back to the email example, whether or not the email is spam is a variable, and specifically it's our response variable, we call it. Another example we can consider is a study where we have recorded the age, number of miles, and prices of the cars at a dealership, say. So here I want you to think about what are the observational units in this scenario and what are the variables. So I'll let you think about this for a second and maybe pause the YouTube video if you want. Okay, hopefully you paused it and thought about it, or if you know it already, that's okay. So the observational units are the cars, and the variables are the age, the number of miles for each car, and then the price. Another key concept that we'll define is a quantitative variable. So a quantitative variable measures numbers describing observational units such that arithmetic can be done or is sensible. And so arithmetic is just adding, subtracting, multiplying, dividing. Those are arithmetic. So anytime we can do those types of operations on a variable and it's sensible, that's a quantitative variable. So common examples of this are measuring someone's weight, their age, say in years, or even the number of pets they have. So age is sort of a continuous variable in that you can have sort of like a decimal or a fraction of an age. You can be 51.215 years old. It's continuous in that you can measure more precisely always. Here, the number of pets is a quantitative variable, but it's what we'd call a discrete variable because it comes in whole numbers. So you can only have 1, 2, or 3 pets. Say you can't have 1.24 dogs. That doesn't make sense. So number of pets here would be a discrete variable, whereas age and weight are continuous variables, we say. We also have categorical variables. So these are also referred to as nominal type variables. So these record a category designation of observational units, which sounds a little bit wordy, but it's sort of just the variables that arithmetic doesn't make sense are commonly categorical variables. So for example, we could have political party where we have Republican, Democrat, and Independent. You can't really add or subtract. You can't say Republican minus Democrat equals Independent. It doesn't really work that way. So political party is a categorical variable. The values fall into these set predetermined categories. Handedness, again, is another great example. This categorical variable with you can either be right-handed or left-handed. So there's 2 categories. And in this specific case, when a categorical variable has only 2 possible categories, it's said to be a binary variable. Another type of variable that we'll define is called a response variable. So I think I mentioned this earlier. So the variable describing the outcome of interest for our study is the response variable. So for example, in the email example again, where Google's trying to estimate if an email is spam or not based on certain characteristics, the response variable is a binary categorical variable of whether the email is spam, yes, or it is not spam, no. So it has 2 possible outcomes, spam or not spam. And this is a binary response variable in that example. Back to the home example, where we were trying to estimate the selling price of a home based on characteristics. That's a quantitative response variable in that the selling price is quantitative and it's the variable of interest. Separate from response variables, we have what we call explanatory variables. So these are variables whose relationship with the response variable we're exploring. Typically, they're referred to as predictor variables as well. So explanatory variables, specifically in regression analysis, are called predictor variables. Again, back to the housing example where we're estimating housing price, the different characteristics about the house, such as the age, square footage, number of bedrooms, those are the explanatory variables if we're trying to predict the selling price of the house, which is our response variable. So for another example, in a study exploring whether a student is accepted to a university or not, where GPA and ACT or SAT scores are recorded, I'll let you think about what is our response variable here and what is our explanatory variables. So I'll let you pause the video and think about it, and then I'll give you the answers. Okay, hopefully you were able to pause it okay. So our response variable here is binary response variable again, whether or not the student is accepted. And our explanatory variables are GPA and the ACT or SAT score. So we're using those scores, the GPA and the scores, to try and predict if a student will get into a university or not. Of course, I'm not saying this is a good idea necessarily to only use those factors alone. I think there's much more that describe the potential success of a student. So another key concept is a controlled experiment. So a controlled experiment is a study in which our explanatory or predictor variables are changed or actually manipulated by the researcher. So common example of this, usually what pops in your head is a sort of a scientific research study where you have maybe a clinical trial. So this is where some participants are given drugs with an active ingredient, and some participants are given a placebo. So, and then we measure some outcome of interest at the end of the study, say life expectancy. And so we can control which participants. We're actually manipulating which participants receive the placebo and which receive this drug. And that's our explanatory variable, an active drug or a placebo. So since we're manipulating this variable ourselves, this is considered a controlled experiment. More commonly, probably data comes from what's called an observational study. So this is just a study in which explanatory variables are not assigned, but just passively observed. So for example, if we're interested in sports analytics, say we're interested in if the Los Angeles Lakers basketball team will beat the Portland Trail Blazers basketball team, which they just did, but let's assume that that game hasn't happened yet. We can measure characteristics such as the average points per game that they have scored throughout the season, maybe the average height of all their players, other characteristics about each team to then try and predict which team will win in their head-to-head matchup in the next time they play each other. So we didn't manipulate or change any of the variables about the teams ourselves. In this case, we just observed them. We recorded them. So this is an observational study. So another basketball example. So a study in which we record students' heights and whether or not they like basketball. So I'll let you think about here whether this is a controlled experiment or observational study. And so if you want to pause, I'll give you a moment to think about it and then give you the answer. Okay, so we recorded students' heights, whether or not they like basketball. So this is a observational study. So we are a researcher and we are actively engaged in this study here, but we did not change the students' height. We didn't set their height. We didn't assign them to like basketball or not. We just recorded how it was in reality. So we passively observed these values. So this is an observational study. Another example, which I sort of alluded to already, but suppose we had a clinical trial in which some patients are given an active drug for lowering blood pressure and other patients are given a placebo. Then the change in patients' blood pressures is recorded. So this is a very biostatistics example. So this is my bias coming in here, but Yeah, so I'll let you think about if this would be a controlled experiment or observational study. Go ahead and hit pause if you want to. Okay, so I think I mentioned this already before with the other example, but this would be a controlled experiment because we are assigning the patients into a certain treatment group. We are manipulating the explanatory variable ourselves. If, for example, we had just measured participants, whether or not they were taking, say, ibuprofen, or if they were just not using any sort of drug to cure a headache, for example, and then we saw if their headache got better, and it was entirely their own choice. We just recruited them because they liked to take ibuprofen and they did it. This would be an observational study. So I guess it's a little bit of a subtle difference, but so if we're not assigning them ourselves or randomizing them to a certain treatment, then it's not a controlled experiment. It would just be an observational study. So another example would be a study in which we record how many hours per week students study and then their final exam scores. So I'll let you think about it again, if this is a controlled experiment or an observational study. Okay, so here, this would be an observational study because we are not assigning or telling the students how many hours per week to study in our research study here. We're just telling them, or just recording how much they reported themselves studying, and then also just observing what their final exam scores are. We're not assigning them final exam scores. Okay, so that sort of covered some key concepts to introduce us to statistical models here. Now I'm going to talk a little bit about R, the programming language that we're going to use in this course, and specifically importing of data. So this just means sort of putting data into our R environment so that we can readily access and manipulate it. So many different file types can be imported into R. Some common file types you might be familiar with are a PDF file, so a .pdf, so that file extension, the last characters on the name of the file, it's the file extension, and that signifies the file type. So there's PDF files. There are CSV files, which stands for comma-separated value files. So this type of file is a common data file, and it's stored in a way such that each data point or data value is separated by a comma. So very fittingly named, comma-separated value. Another type of data file that we'll commonly work with and that's commonly encountered in the world is a text file. .txt is commonly used to signify that. So for example, I might have a data set saved on my laptop about the temperature in Minneapolis across time, and maybe I have it saved as weather.csv because it's stored in a comma-separated value file. In terms of data files, so CSV and TXT are not specific file types to R. These are just general file types we use with computers. But R also comes with, built into itself, some data sets, some example data sets that we can just sort of readily access directly from within R. We don't have to import them from outside, from a different spot on our computers. And these come in R packages and directly in the R software itself. So here's the first R code we've seen so far in this course. Some of you might have prior coding experience, and I know some of you might not as well. So I'm going to assume you do not have prior coding experience. I'm going to try to be as helpful in gently introducing this as possible. Although learning your first coding language, again, is always very difficult still. So make sure to have plenty of patience with yourself and reach out to me for help whenever you feel like it's getting to be a bit much. So for this first bit of R code here, I'm showing an example of reading in a data set into R for our use. So this would be in the R console where this R code would be, so that I can read it into R. And we'll walk through, I'll walk through actually coding in R this Friday with you guys to see live. So, but this is reading in a data set on movies from Fandango. So I use this read.csv function to read in this file. And so this string in here, encased in quotes, is describing the location of the file on my laptop. So it's in my C drive, and the name of the file is fandango_scrape.csv. Then after I've read it into R, into this object I named Fandango data, which I could have named whatever I wanted, I can print the first 4 rows of it using the head function. And here I can see there's 4 variables: the film name, the number of stars it received on Fandango, its average rating, and then the number of people who voted for these. So it looks like people were most a fan of American Sniper and Fast and Furious 7. Those are quite old now, though, of course, 2015. So that was an example of reading an external file into R. We can also read or use data files that come directly built into R. So we can load this mtcars data set using the data function in R. So this is just a data set pre-built into R, and then we can look at some of the key characteristics about this data set using the summary function. So this is just conducting some exploratory data analysis, we would say, of the data set mtcars. And it seems to have 3 different variables: mpg, sil, and HP, which is for miles per gallon, number of cylinders of each car, and then the horsepower. So these are all measures. Each row of this data set is describing a car, and then we have different variables describing its miles per gallon, number of cylinders, and its horsepower. This just gives characteristics about each of those variables across the whole data set. So for example, the car with the least amount of horsepower in the data set had 52 horsepower, and a car had as high as 335 horsepower in the data set, so quite a range. Here's some example R code for creating a histogram plot. So histograms are useful for displaying the distribution of a variable. So just helps us get a feel for the data and can be helpful for identifying outliers as well. This histogram we're creating is for the variable miles per gallon. And I specify that here in the first argument by doing the data set name, mtcars, $, the variable name, mpg. So I'm saying I want a histogram of the variable mpg from the data set mtcars. The next argument to the hist function is main, and I'm just specifying the title of the overall plot. And the xlab argument of the hist function here, I'm specifying the x-axis label as mpg, although I think it might have been cut off. Yeah, unfortunately, it got cut off here in the bottom of the plot, but it says mpg here just below. So here we see this is a histogram of the distribution of mpg. And here are the miles per gallon values on the x-axis, and then the number of times they occur in the data set here on the y-axis. or the frequency. So we can see here, most cars, the most commonly occurring mileage is somewhere between 15 and 20 miles per gallon. So those of you who drive or have your own car might not be too surprised by that. I think a lot of cars are right around here, around 20 miles per gallon in what they get. The poor soul who has one that gets 10 miles per gallon. Oof. Okay, so now we have some code. So we saw a histogram in the previous slide. Now I'm showing you some code for exploring the relationship between two variables at once rather than just one variable. So I'm plotting horsepower here and on the x-axis, and then miles per gallon on the y-axis. And again, I'm changing the overall plot title, the x-axis label, and the y-axis label. So here's what that plot looks like that code produced. So here each circle is representing a data point. So for example, in this data point, this car has a miles per gallon of roughly 25. See, it's about 25 or 24 miles per gallon. And a horsepower of about 52, it looks like, say, 52 or 55. So this is helping us visualize the relationship between horsepower and miles per gallon. And so here we can see there's a negative relationship in that as horsepower increases on the x-axis here, the miles per gallon tends to decrease on average. So this is a negative relationship between the two variables, we say. So yeah, so that was a brief introduction to R and some of the things we're going to be doing with it commonly in this course, as well as some key concepts about statistical models. So now, for you guys to get to use R this semester, the first step is going to be downloading and installing it yourself, which will take a bit of time. So these slides aren't taking the full class time, the full hour and 10 minutes, I'm thinking, for you guys. So I'm hoping you can take the extra time to try and download and install R now. So to use R, we're going to use what's called an IDE, and specifically we're going to use RStudio as our IDE for R. So this makes it sort of simplifies a lot of the tasks and coding in R, even for very seasoned programmers. So it's very helpful and a useful skill to know. So before this Friday, please try and download and install R. I have links for that in the software section on the Moodle page, as well as a link here in the slides. And also please then download and install RStudio Desktop here using this link, or again, using the link in the software section of Moodle. It's important that you do it in this order. We must first download and install just R, base R they call it, and then download and install RStudio in that order. If you have any trouble, feel free to reach out to me by email, or I'll try to help you in class on Friday. Otherwise, this Friday, I will possibly be helping some of you download and install R, and then also I'll be walking through coding in R, so I'll use Zoom to share my screen and then show you guys some basic coding in R, and then save that script for you guys and allow you to try and do something very similar, just with a different data set. So that's what we'll be doing this Friday. So please come. Participation is worth points. It's worth half the points of the R activity is just showing up on Fridays and being there. So please make sure you are there. And these assignment directions for the R activity will be posted to Moodle on Friday during class. So yeah, and then this R activity, which you will submit via a Word doc through Moodle, will be due before class next Monday, September 7th, although we'll have time Friday together to work on. So thanks, and I look forward to seeing you all on Friday.